This video goes over a review that I made for Algebra 2 Module 1 Test 3. Again, as with all of my review videos, I do not recommend that you simply watch the video and copy down the answers and think that you've got it, okay? That's what's called the fluency illusion, where I see this on my paper, I see that I wrote it, I think that I can do it because I can see that my handwriting, but actually if you're given the problem brand new without any reference material, you can't do it on your own. Okay, I highly recommend that you try these problems on your own, you check your answers, try to figure out how to get that answer, and then if you still can't figure it out, then you use this video. Okay, so with that preface, let's start. In number 1, I'm solving a radical equation, and my first step is always to get the radical by itself. Now in this problem, it already is by itself, which is super nice, and so what I do to get rid of my radical is I square both sides of my equation. Okay, now squaring the square root of something kind of cancels out that square root, and you have x squared minus 6x on the left hand side. The right hand side is 4 squared, which is 16. Okay, now this is a quadratic equation that I must think like a quadratic, and so I'm going to get one side equal to 0 and then factor if I can. And so I get x squared minus 6x minus 16 is equal to 0. Now, I can factor this by what I call the simple ABC method, and where I'm looking for two numbers that multiply to be negative 16 and add to be negative 4. Whoa, sorry, and add to be negative 6. Okay, and the numbers that I get are negative 8 and positive 2. Those two numbers will multiply to be negative 16 and add to be negative 6. Okay, and now this is factored. I can use the zero product property to say, well, what number minus 8 equals 0? And that's true for x equals 8. And what number plus 2 equals 0? And that's x equals negative 2. Now, before I am done with this problem, I have to check that I don't get any extraneous solutions. Can I check that by plugging them in? I'm kind of low on space here, but I'll do my best to plug in the square root of 8 squared minus 6 times 8. And does that equal 4? Well, 8 squared is 64. 6 times 8 is 48, and 64 minus 48 is 16, and root 16 is equal to 4. So that one's fine. That is a solution. Okay. For negative 2, I get the square root of negative 2 squared minus 6 times negative 2, and does that equal 4? Well, negative 2 squared is negative 2 times negative 2, which is a positive 4. Minus 6 times negative 2 is a negative 12, but I'm minusing a negative 12, which is plus 12. And that's root 16, which is equal to 4. Okay, and so both of these work. I don't have any extraneous solutions in this problem. I have two solutions. Okay, number 2 is very, very similar. Okay, so if I were you, I would pause the video and try that one again before you finish the video, but I'll keep going. So I'm going to square both sides because I've already had the radical by itself. Okay, again, the first step is always get the radical by itself and then square both sides. Okay, I'm doing that right now. The square and the square root cancel each other out. I get x squared plus 8x is equal to 3 times 3 is 9. Again, I have another quadratic. Okay, I want to get one side equal to 0, so I'll subtract 9 from both sides. It's very similar to the last one. X squared plus 8x minus 9 is equal to 0. I then want to factor, and this is again the simple ABC method. I'm looking for two numbers that multiply to be negative 9 and add to be positive 8. Okay, and those numbers will be positive 9 and a negative 1. Okay, those numbers multiply to be negative 9, and they add to be positive 8. So now I use the zero product property and say what plus 9 equals 0? That's negative 9. And what minus 1 equals 0? And that's positive 1. Okay, now before I think I'm done, I need to check both answers. Again, I'm kind of limited on space, but I'll do my best. I have 9 squared plus 8 times 9, and does that equal to 3? Well, I get 81 plus 72 is the square root of 153, which is not 3. This is not a solution. It's an extraneous solution. It was created as I squared both sides. I added in this extra solution that doesn't actually work. Okay, let's try x equals 1. The square root of 1 squared plus 8 times 1. And does that equal to 3? Well, I get 1 plus 8 is the square root of 9, which is 3. And so I get x equals 1 as a solution. Okay? So again, you will solve for the radical, which is done already in these two problems. You square both sides and you solve that quadratic. Okay? We've done those things like this before. Okay, next we will perform the indicated operation and simplify the following rational expressions. Okay, now the first thing we'll do for, at least for number 3 and 4, is we'll factor everything that we can. Okay, and I'll start that process. So this 2x plus 6 is a GCF of 2, so I get 2 times x plus 3 divided by, I get x squared plus x minus 6. That's the ABC method, the simple ABC method. So two numbers that multiply to be -6 and add to be a +1 is a +3 and a -2 times. Over here, this x squared minus 4, I have the difference of squares. So I get x plus 2, x minus 2, and then I have just 2x. Okay? Now, when you multiply fractions, you multiply straight across. Okay? But one thing that we can do with fractions is we can cross cancel. Okay? When I notice that I already have a common factor in the numerator and denominator, I can cancel that off. Okay? I also have an x minus 2 and an x minus 2. Now, the next one I want to be super, super careful that I'm clear about what I'm doing. Okay, this I see I have a 2 right here. Okay, and I can cancel with this 2 right here because the 2 right here is 2 times other stuff. Okay, I cannot cancel with this 2. This 2, this green 2, is being added to something else to create a big factor, x plus 2 as a factor. Okay, so I can cancel off the 2 that's being multiplied, but I cannot cancel the 2. I'm messing this all up. I cannot cancel the 2 that is being added to something within a bigger term. Okay, so I can cancel this 2, we'll change colors, not have it be red. This 2 and this 2 cancel, and that's fine. Okay. Similarly, I cannot cancel this x and this x because, again, this upper x, this is being added to 2 to create one big factor. You must think about x, plus 2 in parentheses as a large factor, and either the whole thing is canceled or nothing is canceled. Okay, so with that, what do I have left? Okay, what I have left on the top is this x plus 2, and in the denominator I have x. Okay, and for the exact same reasons before, I was still thinking about x plus 2 as one big factor, and so I cannot cancel the x in the numerator and denominator. This right here is my answer in simplest form. Okay, that's how you multiply rational fractions. Is you factor everything, you cancel, you cross cancel by canceling numerators and denominators that are the exact same, and you write what's left. Okay, number 4, we are dividing fractions, and again, you will still factor everything that you can. Okay, now before that, let's think about division, and the better mathematical approach is that instead of dividing, you want to multiply by the reciprocal. Okay, but in practice, it's the exact same as what's been coined as keep, change, flip. And so I'll keep the first fraction. I will change the sign and flip over the second fraction. Okay, I'm multiplying by the reciprocal. Okay, and now I'll factor what I can, and just to conserve some space, well, I'll just write it below. So x squared minus 4 is the difference of squares, and so I get x, and what squares to be 4, and I get 2, so I get plus 2 minus 2, divided by 3x times 2x over x minus 2. Now, I get to cancel off, I get to cross-cancel things that are the same in the numerator and denominator, and I have an x minus 2 and an x minus 2. Okay, and from our prior discussion, hopefully you can see that we can cancel off this x and this x because it's multiplying by something else. It's not with anything to create a larger factor. Okay, even though it's written 2x, 2 times x is multiplication, and so those are two separate pieces. Okay, what's left? I have still this 2, so it's 2 times x plus 2 divided by 3. Okay, that's multiplying and dividing fractions. All right, number 5, we are subtracting and adding fractions. Now, this is where you have to find a common denominator. Okay, but it's super important that before you find a common denominator, that you factor that denominator. Okay, otherwise the problem gets really messy. So for example, number 5, I multiply top and bottom here by x squared minus 1. Okay, don't do this, by the way. And this by x squared plus x minus 2. It gets really messy. You have like, cubic equations to deal with. It's really messy, so don't do that. You first want to factor the denominators. Okay, over here, x squared minus 1 is the difference of squares, and so I get x plus 1 and x minus 1. Okay, is that. And over here, x squared plus x minus 2 is the simple ABC method. And two numbers that multiply to be negative 2 and add to be positive 1 is a plus 2 minus 1. Okay, and now I'm actually thinking about not looking at this, looking at the bottom thing that's factored. Okay, and now I'm looking for that common denominator that you have to have when you're adding and subtracting fractions. Okay, I notice that this left side does not have this x plus 2. So I'll multiply top and bottom by x plus 2. Okay, and that the right fraction is missing an x plus 1. Okay, so now on both denominators I have x plus 2, x plus 1, and x minus 1. So I now have a common denominator. Okay, I will take this in small steps, and so let's write this as x times x plus 2 divided by my common denominator, okay, minus a 2x times x plus 1 over x plus 2. I'll write the order so that they're both the same, so it's very clear that I have a common denominator. Okay, and now I'll distribute. I'll distribute this in, and I get x squared plus 2x on top. Okay, times divided by my common denominator. Okay, now one thing that I do to make sure that I take my negative with me as I distribute is I think about this as a negative 2x. Okay, so negative 2x times x is a, how to write this? I'm going to pull these into one big fraction already. Okay, that should be easier for me. Okay, negative 2x times x is a negative 2x squared. And negative 2x times 1 is a minus 2x. Okay, and those are all into the same fraction because they have a common denominator. So now I want to simplify the numerator. I will leave the denominator factored with the same common denominator. Okay, and as I combine like terms, I first start with my x squared term, and I have x squared and minus 2x squared, and I have a minus x squared. And then this 2x and this negative 2x actually cancel, And I'm left with this as what I get when I subtract those two rational expressions. Okay, so a lot of steps there. You want to first factor the denominator to look for your least common denominator. Okay, that will make a lot of things honestly simpler. I then find my common denominator by multiplying top and bottom by the missing factors. And then basically it's a process of simplifying your numerator. You're getting your numerators to be, to expand things so you can combine like terms, and that's how you go. Okay, on number 6, I'll do the exact same thing. I will start by factoring both denominators. B squared minus 4 is the difference of squares, so I get b plus 2 and b minus 2. Okay, and b plus 2 can't be factored. That's as simple as it gets. Okay, so now I look for the least common denominator, and it's this b plus 2, b minus 2. And so the left-hand fraction is fine. Okay, the right one, however, is missing a b minus 2 on top and bottom. Okay, so now I have a common denominator. Okay, and I'll write that all together with the same common denominator, b plus 2, b minus 2. Okay, and the numerator I'll write as b squared plus 1 plus, if I distribute the 1 in, which doesn't make a lot of sense because it's just 1. 1 times b is b. 1 times negative 2 is negative 2. Okay, and now I'll combine like terms. Okay, I get b squared plus b, and then 1 minus 2 is a negative 1, over b plus 2, b minus 2. Now, one word of caution to let you know about before we box this and say I'm done, is if I could factor b squared plus b minus 1 so that a b plus 2 or a b minus 2 would cancel, then I should do it. Okay, but b squared plus b minus 1 is not factorable because there are no numbers that will multiply to be negative 1 and add to be positive 1. So I can't factor the top, and so I will stop right here, and this is it. Okay. One more thing to point out here in 3, 4, 5, and 6 is the directions say to comment on what the variable cannot be that will give you division by 0. I'm not worried about that. When you're simplifying, you have to look at that when you're solving, and we'll look at that right now. So when you're solving equations, you will need to check for extraneous solutions, and that's to make sure that what you get as the answer doesn't give you division by 0. So here we go. The first thing I do is I think of this a lot like addition and subtraction, because I have addition and subtraction. Okay, so I'm looking for a common denominator as my first step. Okay, and I'll factor the denominator. M squared minus m has a common factor of m, and so m times m is m squared, and m times negative 1 is negative m. Okay, this middle m can't be factored anymore, and this one over here, m squared minus m, is the exact same thing. I get m times m minus 1. So it looks like my first term and my last term already have my common denominator. That's fine. I have 1 over m times m minus 1. This second term, though, 1 over m is missing. Actually, I want to change colors just to kind of make this really obvious. It's missing an m minus 1 on top and bottom. Okay. Equals 5 over m times m minus 1. Whoops, I missed my open parenthesis here. Okay, so now I have a common denominator of m times m minus 1. And the best way I think to think about moving forward is that I want to now focus on the numerators. Okay, I have a common denominator. As long as my numerator is equal, then my denominator will also work out as well. Because they're all the same. Or I will now have the same size of piece, so I can focus on how many pieces to deal with in fraction terms. Okay, but I get 1 plus, let's distribute this at the same time, m minus 1 equals 5. Okay, so focusing on that equation, I'm going to combine like terms. M is M. 1 minus 1 is 0, so you get M equals 5. Okay, now before you box it and say I'm done, make sure that you don't get division by 0. If I plug 5 into here, I don't get 0. And plug 5 in here, I don't get 0. Okay, I get 5 times 5 minus 1, which is 5 times 4, which is 20, not 0. Okay, I do not get division by 0, so this is my solution. Okay, in number 8, it's very similar. I'm again factoring my denominator. I don't have anything to factor. That's even easier. It looks like n minus 8 will be my common denominator, so I'll write this 1 over n minus 8. That term is fine. This 1, I'll think about like a fraction, 1 over 1. Okay, and so I need my common denominator of n minus 8. So I'll multiply top and bottom by n minus 8, equals 7 over n minus 8. Okay? Yeah, and so just like before, I will pull off my numerator. I want this to be not red. Pull off my numerator and focus on that as I have a common denominator for all my terms. So I get 1 minus, I'll just say it like that, n minus 8, and deal with that negative as I go forward. Okay, I'm going to distribute this negative 1 into both of these terms, and I get 1 minus n, and negative 1 times negative 8 is a positive 8 equals 7. So I get negative n, 1 plus 8 is 9 equals 7. I'm going to subtract 9 from both sides, and I get negative n is equal to negative 2. If I divide both sides by a negative 1, I get n is equal to 2. Now, before I box that and saying I'm done, double check that if I plug n back in here, I don't get division by 0. If I plug it back in here, I get 2 minus 8, which is negative 6, and I don't get 0. So n equals 2 is my solution here. Okay, so that is solving a rational equation and checking for extraneous solutions. The last problem is to identify key elements of a graph and sketch the graph for the function g of x equals negative x to the fourth plus 2x cubed plus 3x squared. Okay, the first thing we typically look for is end behavior. So here's my graph that I'll draw eventually. Okay, if I first look for end behavior, okay, I'm looking at the very first term, this very first term, okay, whoops, x to the fourth. Okay, and this is even and negative, even power, and it's negative. Okay, and as I taught before, if it's even, then it's either up, up, or down, down. It's the exact same as, you know, squaring negatives and positives give you the same thing. Okay, and the number, the sign in the front will tell you how it ends. Okay, it's going to end negative, and so it must start negative. This is down, down. Okay, that's the end behavior. It's down, down. Okay, the next thing we typically look for are the x-intercepts. And the x-intercepts happen when the function equals 0. So I'm solving the equation 0 is equal to negative x to the fourth plus 2x cubed plus 3x squared. Okay, now this is a fourth degree, and the first thing I do with factoring is I look for a GCF. You always, always, always start with a GCF. There is luckily a GCF in this problem, and that is x squared. But my first term is negative, and so I usually like my my first term when I'm factoring a trinomial to be positive, and so I'll pull out a negative GCF, a negative x squared as my GCF, and what I'm left with is a positive x squared, and then negative x squared times what is positive 2x cubed, and it's a negative 2x, okay, because a positive times a positive is a negative. Whoa. A negative times a negative is a positive. I got to make that a negative 2x. Then negative x squared times what is a positive 3x squared? It's a negative 3. Okay, so I've factored out a negative x squared. And then I want to factor this trinomial that's left, this 2x, this x squared minus 2x minus 3. And that's the simple ABC method. I'm looking for two numbers that multiply to be negative 3 and add to be negative 2. And those numbers are negative 3 and positive 1. So I've now factored that equation, and I will look for zeros. Okay, this first one is a tricky one for us. When is that equal to 0? It's 0 when x is 0. Okay, but it's x squared, which means it's a multiplicity of 2. Multiplicity of 2, which means it's going to bounce right there. So at x equals 0, it's going to bounce. And I needed some indexes for my graph. Okay, at 2, it's going to bounce. Sorry, at 0, it's going to bounce. Okay, the rest are kind of easy. What number minus 3 is 0? It's x equals 3. That's multiplicity of 1. That's kind of like we're used to. And then x plus 1, what number plus 1 is 0? That's negative 1. And so negative 1. Okay, it's gonna cross at negative 1. So here we go. I'll make it, I don't know, red. Okay, so I'll start in down. I will cross, I will bounce, and I will cross. Okay, so this has the right end behavior. It's down, down. Okay, I will cross at negative 1, I will bounce at 0, and I'll cross at positive 3. Okay, let's see here. Identify the key elements. Let me kind of make sure I've identified my intercepts. So at negative 1 and at positive 3, I have, and at 0, I have those. Okay, that's good enough for me. Okay, so this is, again, Module 1, Test 3 review. I hope that was helpful. Again, just watching a video is not going to make you acquire the skills that you need to do well on this test. And so maybe reprint off a blank one of these after watching this video. Try them on your own. Pulling things from your own memory is the best and most efficient way to study. All right, thank you so much for watching.